Okay, so today we will talk about media access control protocol. As I earlier told you that data link layer. Are you able to hear me now?
Yes, sir.
Okay, so your DLL, this is as per IEEE 802.3 standard. It IEEE, sorry, it is called 802 point standard. Data link layer is divided into two layers actually. One is called DLC, data link control, and second part of that is called MAC. Okay, I think we should display like this, MAC, and here you have DLC. Hmm? So the MAC layer is different for different LAN technologies. So data link layer is actually uh, depends on what kind of LAN technology you are using. Okay, so your data link layer is generally having is divided into two portions. First is DLC, data link control. It is called a data link control. Okay, and second is media access control or medium access control. Medium access control. Okay, so usually whatever LAN technology you are using, this part is actually common to all the layers. So that's why this is done. So common part is added into this link layer, that is called data link control, and usually in different LANs MAC is usually MAC is different. So this layer varies across different LANs. Okay, like Ethernet, which is a LAN, it will have different MAC that we will talk about later. It is CSMA/CD. Then if you talk about Wi-Fi have different MAC. Okay, and similarly some more standards, IEEE 802.4 and IEEE 802.5, they use different kind of MAC layer. Okay, so this you should remember. Now let's talk about what is medium access control. So as I earlier told you that when two devices want to communicate, so there may be two kind of scenario. One thing is that these two devices, suppose this is your sender and this is receiver, they want to communicate. So suppose that there is a dedicated link. This is a dedicated link. It is also called point to point link. When there is a dedicated link between sender and receiver, you do not require to do anything for controlling the access of the data actually. However, you will require some protocol so that these parties can communicate properly and efficiently with higher link utilization. So we have a example of the protocol for this purpose is PPP, point to point protocol. Okay, but sometimes your link may not be dedicated one, the link is shared one. Like it is called usually broadcast link. So for example, there's a scenario like this. Suppose this is a backbone cable, and here are the terminators of the cable, and these cables are these cable is connected with different computers, or different computers are connected to this cable by just adding a cut and applying connector here. So now you see that this layer, sorry, this link is being used by all these nodes. So this is a kind of common facility that everybody will use this link. Like you can see that lift in your building, it is a kind of common facility. Everybody can use that link, that lift. So similarly, this link is common to all. So suppose this node and this node want to communicate, they will use this link actually. Similarly, this node want to suppose communicate with this node, they will use this common facility. So now here it is important that in such scenario, this is also called multi-point or broadcast link. You can see here broadcast link or multi-point link. So here you need to regulate who can transmit next. Okay, so here the important question is that who transmit next. This question need to be addressed properly. Who transmit next? Okay, why we want to address this question? Because suppose that at the same time these two party want to transmit. So now if though both the party will transmit their signal onto this cable, so both of the signals will become combined signal, and they will form a different kind of signal that the receiver of the receiving machine not to be able to decode. Okay, so that's why we want to avoid this situation, and this situation is actually known as collision. So we want to avoid this collision. So in order to avoid this collision, we need to regulate who will transmit next. Okay, so that means one party should transmit all at a time only. If two parties transmit simultaneously, their communication will go into waste due to signal collisions. Okay, so that's why we require a protocol to govern the use of this link. Okay, these protocols are known as MAC protocol or media access control protocols. Okay, got it? Any doubt? Okay, so let's move ahead. Now there are variety of protocols are there. A number of protocols have been proposed into the literature, and many protocols are being implemented, has been implemented actually over different network technologies. So let's talk about a classification of these protocols. We can classify these protocols like this. One category is random access protocol, second category is controlled access protocol, then third is channelization protocol. So in this class, actually in this course, we will talk about preferably random access protocols like ALOHA, CSMA, CSMA CD, and CSMA CA. So in case of random access protocol, what happens? The nodes actually compete to grab the link. Okay, so here obviously collision may be there, then you need to handle the collisions. We will talk about these protocols in detail. So in case of random access means any node can transmit anytime. Okay, they are not governed or they are not given a pre-specified you should follow this only, these set of rules, these actually pattern, and you can transmit accordingly. Then there is a controlled access protocol. Controlled access protocol of the category where you need to the machines need to work in a completely controlled environment. So that you can understand this by example. Suppose that there is one app, you want to go to lunch in some restaurant. Okay, so one approach you can follow is that you can directly go to the restaurant, right? And then have a lunch there. Okay, now you see that in this case it may be the case that if you are lucky, you may get a empty table and you can sit there and take the you can order your lunch and then complete your lunch. Okay, so here you are just randomly going there. Okay, you are not doing a kind of pre-planning kind of thing. Then there is another option. You can have a reservation, and once you get reservation, you can go at the time when you have got reservation, and to the seat which you have reserved. Okay, and then you can order your lunch and you can finish your lunch. So now both categories are both the things are possible. So the one possibility where you was just decided to go to the lunch and just went there and had a lunch there. Now it may be the possibility when you are following this approach without reservation you are going, then it may be the case that if you are lucky you may find the empty chair, empty table, dining table, or maybe that all the dining chairs are occupied and a number of people are waiting for that. Okay, so at some peak region or some specifically the region, the time when most of the people are having holidays, or some specific event is there, maybe some festival season, or maybe season where that is the season where most of the time people are going dine out, like maybe uh, maybe new year day is there, so everybody want to go to have a lunch on restaurant. So there may be certain scenarios where you may have to wait, okay, or you have to compete for the chair. There may be that you went there, and there were some chairs were empty, but lot of people were there, and they attempt to grab that seat. Okay, so such approach is known as random access approach. So there are protocols that follows this approach. Then there is a category of protocols where they follow reservation kind of thing, or some other different kind of thing. Okay, so in this case we call it, these are the control access protocol. So in case of control access protocol, we have reservation based protocols, then polling based mechanism, or token based systems. Okay, then we also have some channelization based protocols, where we divide the communication channel in the complete communication link into different channels, and we can allot by following certain mechanism the channels to different stations for doing transmission. So these are the three broad categories. We will focus mainly on this set of protocols. Okay, so now before diving into these any random access protocol, first let's understand uh, let's what are the requirements a channel access protocol should satisfy. Let me take one page. Did I got a page? Oh, empty pages, it is not inserted. Okay, so let's do one thing. Any question at this point? No. So let's talk about what are the requirements a MAC protocol should satisfy. MAC protocol requirement. Okay, why we are talking about MAC protocols requirement? The reason is that you have multiple MAC protocols. So the question, naturally a question will come in front of you, that which protocol we should use. Okay, so obviously you need to have certain criteria. On the basis of that, you can evaluate the options that you have, and then you can find out best option that is available for you. Okay, so there are certain points or certain criteria or features on the basis of we assess MAC protocol. So first criteria is fairness. Now why fairness is important? Let's come back to our earlier example. As I told you that this link is shared one, and everybody is competing. Okay, so why fairness is important? Because everybody should get equal chance. So why fairness is important? Because n people are competing, or n stations are competing for broadcast or transmission. N stations are competing. So station means node. Okay, there may be more than one party that want to use the channel. Okay, so they are competing for getting the channel. So everybody should get a fair chance. It should not be there that some stations are getting some certain preferences and some are not getting. There are some set of stations that usually easily get the access to the channels. Some may not be able to get the access to channel. So if a protocol doesn't support fairness, then the protocol may not be useful for you. Okay, however, in sometimes you may want to compromise fairness. You want to give priority to certain number of nodes. Okay, किसी केस में हो सकता है कि आपके लिए रिक्वायरमेंट हो कि यू वांट टू गिव सर्टेन प्रायोरिटीज, certain nodes higher priority than in comparison to others. in that case you may not worried about fairness, and you can ignore this feature. But in some cases it may be very important that every station should get fair chance for transmission purpose. Okay, then there is another concern that you will be worried about, that overhead. Now why overhead? Because when, let's say, 2 or 3 stations are want to get a channel, so obviously channel is not dedicated channel, so it is a shared channel. So now all these parties that are willing to access the channel, they should come into a common point कि कौन transmit करेगा आगे. सब तो नहीं transmit कर सकते, they collaboratively need to decide that who will transmit. Okay, so obviously the MAC protocol will require that these parties should exchange certain messages, and so that they can collaboratively, directly or indirectly decide कि कौन आगे चैनल को एक्सेस करेगा. एंड देन जो डिसीजन हुआ है उसके अकॉर्डिंग वन पार्टी विल गेट द चैनल, एंड रेस्ट ऑफ the parties will defer their action and they will try at some other time. Okay, so in this case obviously they are communicating, so they will share certain messages that are completely control messages. So that means the control messages will be transmitted among the channels, among the nodes over the channels, so that they can grab this access. So if a protocol requires lot of control messages to be exchanged, then that we will say that there is a lot of overhead is there. So what we want to minimize this overhead. So a protocol will be called very good if it have less overhead, और बहुत कम messages में आपस में एक decision हो जाए, and nodes will be able to access node will be able to access the channel. Okay, so that is the main point, overhead. Then there may be channel access delay. That is one point, channel access delay. So channel access delay means, so obviously it may be the case that these parties are competing, so they will communicate with each other so that they can decide who will transmit, or the protocol will be there that will govern who will transmit next. So this decision will take some time. This decision will require certain time. These competing nodes have to reach on a consensus, or protocol should establish a consensus among the parties that who will transmit next, so that this decision will take some time, and once this decision is made, channel can be given to the party who have given access. So obviously it will incur certain delay. So what we want, this delay should be minimum. And one more thing, we also would like to have this delay, many times we would like to have that this delay should be a constant value, fixed value, but sometimes it may not be the case, especially in case of contention based protocol. So we want that this delay is usually minimum and bounded. This delay should be bounded, it should have an upper bounded कि इससे ज़्यादा delay नहीं लगेगा. So channel access delay should be minimum and bounded for a good MAC protocol. Okay, and next point, the MAC protocol should enhance or should achieve highest throughput, it should give maximum throughput. That is also another criteria, maximum throughput. Then they are related, throughput or / channel utilization. थ्रूपुट मतलब ज़्यादा से ज़्यादा डेटा ट्रांसमिट होना चाहिए. देन नेक्स्ट पॉइंट है चैनल यूटिलाइजेशन. सो दोनों रिलेटेड है. सो चैनल यूटिलाइजेशन मीन्स योर बैंडविड्थ शुड नॉट बी वेस्टेड टू मच. यू नो दैट when control messages are being exchanged, so you are actually using your bandwidth, but you are not actually using it for data transmission. You are just using for taking a decision that who will transmit. Okay, so in some protocol it may be the case that lot of bandwidth is consumed before actually doing transmission. So it will have less channel utilization. So we want that throughput should be maximum. That means data rate you should get higher, then channel utilization should also be higher, or bandwidth utilization, we can say bandwidth utilization also should be higher. So these are the some of the features that we expect from a MAC protocol. Sometimes we say that in contention based protocol there may be one option that we will talk, that collision should be minimum. Okay, so these are the some of the points on the basis of that we decide on the basis of these points we can decide which protocol is best suitable for your need. You will decide your need, and on the basis of your need you will decide which feature is most important for you, or what set of features is more important for you, and accordingly you can evaluate a different options you have, and you can come up with a specific MAC that you can use. Okay, so this is the important point that you should understand, that these are the some of the parameters on the basis of we decide which MAC is good to use. Okay, so now let's come to our category of MAC protocols. So we will discuss random access protocols in this class. Okay, so as I told you that there is one category of protocol that are called random access protocol. Okay, so what happens in random access protocol, uh, the stations actually allowed to transmit whenever they have data. Whenever they want they can transmit. So that means you are not giving any specific timeline, deadline, or interval case. Within this interval you can transmit. So in case of random access protocol, any station can transmit anytime, and no station is superior and no station is inferior. So that means all stations are equal, and any station can transmit the channel or can try to grab the channel. Okay, so since we are giving freedom to all of everyone, that anybody can use. For example, suppose you see that in case of your school's building there is a lift. So anybody, any student or any of you can use the lift. Okay, so if some many people, so there are large number of students who want to use lift, then they have to compete. Like you might you also see this scenario in your hostel at actually where you need to compete for lunch, getting lunch. So such kind of scenarios where the entities are competing, those systems are called contention based systems, or random access system. So there are categories of protocols where we have we follow this approach. We say that a node can compete with each other, or nodes should compete with each other to get the channel. Okay, and each node is equal. So such kind of protocols where node are competing independently are called random access or contention based protocols. Okay, so now obviously it may be the case that you are saying that suppose this is a broadcast channel and these are the nodes that want to transmit. So since this is a channel, so everybody is competing. So it may be the case that two stations start transmitting at the same time, and their signals become mix up. Okay, so this situation is known as collision. And as I already told you that when two stations transmit simultaneously, we say that a collision have occurred. And what is the meaning of collision? Collision means two signals has been combined and formed a signal that this receiving device cannot decode. Okay, so these methods have evolved from, so all these random access methods actually that we are going to discuss after in a couple of classes. These methods are actually developed from a very interesting protocol that is known as ALOHA. Okay, so ALOHA was the earliest protocol that was proposed in this category, and this protocol was very simple, and it is called multiple access protocol. So it is a very simple multiple access protocol actually, and it was the first protocol. And then people started improving on this Aloha and come up with different protocols that were incrementally improvement of this protocol actually. So this, you can say that uh, this is the protocol, ancestor protocol, you can say. This is the ancestor protocol for majority of the contention based protocol. Okay. Hmm. So let's talk about this Aloha. So this protocol was developed by Norman Abramson and his team at University of Hawaii in early 1970. So this protocol is actually having a very interesting story. I guess I remember that I already talked about you this story briefly. So let's repeat that story again. So actually the scenario was that this protocol was developed at the University of Hawaii, and the University of Hawaii actually was actually spread across multiple islands actually. So you can, these are the these points are representing that this University of Hawaii was not at a single island. It was spread across multiple islands. So this university was having a computing facility that it wanted to share by all other universities, schools or departments that were spread across these islands. Sorry. Okay. So now what was the case that, suppose at one point you can think of this was the central island where computing facility was there, and that complete computing facility was to be accessed by every other departments that were available across different islands. So now this was the one solution was in the mind, usually comes to your mind, is that why don't you laid the cables? But you know that these are the islands, so it was very difficult or almost impossible or very costly actually at that time to to have a link through water actually. So it was very costly. So what Norm Abramson did, Norm Abramson actually, that's why he go for wireless communication. So he decided to offer to connect this this point where it was the computing facility through wireless. So different departments that are here, they can communicate or they can access this facility through wireless communication. So that's why he developed a wireless protocol, and this protocol was named as Aloha. So Aloha means hello. It is actually its a synonym is hello. uh, so this so using this protocol Aloha, he actually developed a computer network, or you can say that a kind of LAN technology that was named as Aloha Net. Aloha Net. So the network for that, the network that used Aloha was Aloha Net, and this was developed by, I already told you that, Norm Abramson and his team. Now let's talk about how this protocol works. So now what will be there? So suppose that there is a central computing facility here, okay, or there may be, let's say, a very powerful computer that want to be shared by everyone, and here you have different stations that want to access this computing facility. Okay, so what Aloha says, Aloha, this is, you can image, you can think of now, this is a contention based protocol, because you every station will broadcast. So suppose that now you want to do certain computing through this computer, you need to share your message using wireless to this send machine, and also suppose that at the same time a message also comes from this island or a machine from this island. So what will happen, both the signals will collide here if they are transmitting at the same time. If they are transmitting at the same time, then a collision will happen, you know? So now let's see what is ALOHA protocol. So ALOHA protocol was very simple. So the protocol says that each station is independent and any station or any machine can transmit whenever it needs. Okay, so that means any machine can transmit. There is no restriction. Whenever they require, whenever a machine have data to exchange or communicate, it can communicate immediately. So now it may be the case that obviously if suppose only this party is transmitting, so it will send the message will be processed here and then you will get the response. So if only you, this is the party that is communicating, there is no issue. But suppose at the same time this party or let's say this party, both parties send the message to this. So since this is a message coming on wireless medium, so both signals will may combine if they are coming at the same time. So what will happen? This party, this machine or this server that is having a receiver will not be able to decode the signal. Okay, because now it is going to get a different kind of signal, so it will not be able to decode that signal, and that's why we say that collision will happen and this communication will go into waste. Okay, because this will not get anything, actually it will not understand anything, so this communication will fail. So this why the protocol doesn't restrict any. ALOHA says that if a station, the rule is simple, the rule is like this: if a station is having some data to exchange or data to transmit, it can transmit immediately. Okay, so now obviously then you know that there are high probability that collision will take place. If suppose multiple parties are competing, then collision will take place. So once collision happened, then this algorithm have a mechanism. Actually this algorithm ALOHA actually calls a ALOHA stations that are the stations that are participating in this collision will follow a algorithm that is called exponential backoff algorithm. Okay, exponential backoff algorithm. Sorry, it is called binary exponential backoff algorithm. So what binary exponential backoff algorithm says, let me explain it in briefly. Now what suppose this algorithm is actually called when a collision takes place. So when a collision takes place, so suppose that n node are participating in collision or some collision had happened. Okay, so now what these stations will do, all the stations that are that have participated in the collision will wait for a random time. What will be the random time? So you know that this ALOHA protocol will have a frame transmission time. So frame transmission time, the time that is required to transmit a frame, and then RTT, that means आपने frame भेजी और उधर से reply आया. So this time you can call it TF, frame transmission time. Okay, frame transmission time कितना है? When frame transmission will become complete, or when we will assume that frame transmission is complete, you send a packet and then you get the response. That means acknowledgement. So ALOHA actually uses acknowledgement feature. Okay, you know that क्योंकि जब तक आप ट्रांसमिट करेंगे आपको मालूम नहीं चलेगा, रिसीवर आपको नहीं बताएगा कि आपका ट्रांसमिशन सक्सेसफुल हुआ या नहीं हुआ. So how a station will be able to know कि my transmission is successful or not? When a station transmits something and when it's receive acknowledgement, it will assume that my transmission was successful. But if it doesn't receive anything, that means collision have happened. So now when a collision happens, then the parties, all the stations that are participate in the collision have to enter into exponential backoff algorithm, binary exponential backoff algorithm. So this binary exponential backoff algorithm says that in the first round, when collision happens, all the stations will generate a random number between 0 and 1. Okay, and they will multiply this random number by the frame transmission time, let's say TF. So so obviously some nodes in that participate in the collision will wait for zero amount of time, that means they will transmit immediately. But some node who are unlucky, जिनका नंबर 1 आया है, उन्होंने रैंडम नंबर जनरेट किया, they got 1, so they will wait for TF time. So obviously now what will happen, if two stations were participating in the collision, then एक since the numbers are being generated randomly, so एक का मान लेते हैं नंबर 0 आएगा, तो दूसरे का 1 आएगा. So obviously one station will wait for 0 time, that means it can transmit immediately, but other station will wait for TF time, so that means it will defer its transmission mechanism, that means it will not transmit. So obviously if two party were actually participate in the collision, then you see that एक ही party transmit करेगी and other party have deferred its transmission decision, so transmission will become successful. Okay, so this was the possibility when only two parties were communicating. Now suppose that when two parties we just follow this step, so this was the first step of your binary exponential algorithm, then it may be the possibility that कि जो स्टेशन जिसका जीरो आया था टाइम जो कांस्टेंट जीरो आया था, सो उसने इमीडिएटली ट्रांसमिट किया, बट स्टिल व्हाट हैपेंड, ए कॉलिजन टुक प्लेस. सो इसका मतलब क्या हुआ, देयर मे बी मोर देन वन स्टेशन जिनका रैंडम नंबर जीरो आया था, दैट मीन्स देयर वाज मोर देन टू स्टेशन हु वर कंपीटिंग फॉर गेटिंग द चैनल. सो दो होते तो यहीं रिजॉल्व हो जाता. इफ टू वर मोर देन टू स्टेशन वर देयर, ऑब्वियसली पहले राउंड में पहले रिट्रांसमिशन अटेम्प्ट में यू द स्टेशन विल नॉट बिकम सक्सेसफुल. Okay, so obviously then exponential backup algorithms assume that if first step was not successful, then next attempt mein this time should grow. So what it will do, now it will say that generate random number in this range 0 1 2 3. Okay, so now suppose that there are stations, so किसी स्टेशन का रैंडम नंबर 0 आएगा, किसी का 1 आएगा, किसी का 2 आएगा, किसी का 3 आएगा. सो जिसका 0 आएगा दे विल वेट फॉर 0 टाइम, जिनका रन टाइम नंबर 1 आएगा दे विल वेट फॉर TF टाइम, जिनका नंबर 2 आएगा दे विल वेट फॉर 2F टाइम 2 TF टाइम, जिनका नंबर 3 आएगा दे विल वेट फॉर 3 TF टाइम. सो ऑब्वियसली सपोज दैट अज्यूम करिए कि एवरीथिंग इज आइडियल एंड दीज नंबर्स आर बीइंग जनरेटेड विथ यूनिफॉर्म डिस्ट्रीब्यूशन. सो only one station will have 0 and rest will wait for longer period according to the number they have generated. Okay, so one station will transmit and then its transmission will become successful. Now this will become only possible when only, let's say suppose less than 4 computers was involved in the collision, so then the transmission will become successful. But it may be the case that the number of computers that were participated in that collision were higher than 4. So it may be the case that there are two stations जिनका number 0 आया, 2 या 2 से ज़्यादा का. Okay, so they will again collide. Okay, so in order to resolve it again further, what we will do, we will increase this interval 0 1 2 up to 7 तक चले जाएंगे. So now you are seeing that इटरेशन 1 में हमारा नंबर क्या था, 2 की पावर 1 माइनस 1. सो रेंज क्या थी, इटरेशन 1. फॉर इटरेशन 1 दिस एल्गोरिथम सेज दैट यू नीड टू जनरेट i इक्वल टू 1 के लिए दिस नंबर यू नीड टू जनरेट 0 एंड 1. सो इसका मतलब क्या हुआ, आपके जो नंबर्स हैं 0 से लेकर के 2 टू द पावर i माइनस 1 तक होंगे, है ना. 2 की पावर 1 करोगे आप, 2 की पावर 1 माइनस 0 से 1. So ith iteration, if you are using ith iteration, then the numbers that random numbers that you will generate will be between 0 1 and so on 2 to the power I minus 1 इस रेंज में. और इसे आप फिर क्या करेंगे, TF से मल्टीप्लाई कर देंगे. सो ऑब्वियसली ith राउंड में I may be 1 2 3 4 whatever, I can go for 1 2 and here generally we follow जो इस पर अपर बाउंड लगा देते हैं और I will be 15 or 16. so actually it is I guess it is 15. let me check it. This value this usually is 15. so okay, so this is how exponential algorithm works. So now this algorithm is very important. You should remember that this algorithm is used by all other following protocols also. Okay, सो दिस वैल्यू इज कॉल्ड के मैक्स, मैक्सिमम, मैक्सिमम अटेम्प्ट कितने हैं। ऐसा नहीं कर सकते कि आप बार बार कोलिजन हो रहा है, यू विल अगेन फॉलो एक्सपोनेंशियल एल्गोरिथम। सो हो सकता है आफ्टर 15 अटेम्प्ट यू आर नॉट सक्सेसफुल, सो यू कैन गिव अप योर ट्रांसमिशन एंड देन सारे स्टेशन अपना प्रोसेस को ऑफ कर देंगे एंड दे विल ट्राई इट लेटर टाइम। ओके, so this is how ALOHA protocol works. Now, do you have any question? Hmm? Okay, nobody is asking questions, so let's continue. Okay, so now let's talk about how the collision takes place. So you can think of like this: suppose this station 1 is transmitting, so you see that at this point of time, at this duration, only one station is transmitting, so this transmission will become successful. But you follow this point of time, here you see that four packets are being transmitted, so they will involve in a collision. So there is also a collision, there will be no collision. Okay, so now we need to identify how to get maximum throughput, or when we will get better throughput. So this is the protocol, complete protocol that we have discussed. You can just have a look on this. I have explained whatever I wanted to explain. Okay, so in case of pure ALOHA, you need to define a term that is called vulnerable time. So vulnerable time is a time where that tells you that within this period, if another station transmits, no transmission will become successful. Okay, so vulnerable time means we define a time duration. Vulnerable time is a time duration that says that if within that duration, so suppose this is the duration, vulnerable time, it is a time duration, within this duration suppose only one frame is transmitted, then your transmission will become successful. Okay, so but if within vulnerable time there are more than one frame, then there will be definitely a collision. So let's try to understand this type. Suppose that this is a frame A which is being transmitted. Okay, now you see that this is another frame, so this is the time. On this axis you have a time. Okay, so let's say at this point of time your frame is transmitted, and you know that your frame transmission will be completed after TF time, TFR or TF time, as I told you that मतलब आपने ट्रांसमिशन किया सक्सेसफुली, तो सपोज यू सेंड अ पैकेट एंड देन यू गेट रिस्पॉन्स, तो द टोटल टाइम इज कॉल्ड टी एफ. सो यहाँ से यहाँ तक का जो टाइम है दैट इज टी एफ टाइम. इस पॉइंट से इस पॉइंट का टाइम है टी एफ टाइम. दिस टाइम इज टी एफ. ओके, नाउ यू सी दैट अगर आपका फ्रेम इस टाइम पर स्टार्ट हुआ है ट्रांसमिशन और यहाँ पर कंप्लीट हो रहा है, तो इस ड्यूरेशन में अगर कोई भी फ्रेम ट्रांसमिट नहीं होती है तो यू आर सक्सेसफुल, है ना. योर ट्रांसमिशन इज सक्सेसफुल लाइक दिस. यू ट्रांसमिटेड अ फ्रेम एंड देन इन दिस ड्यूरेशन किसी और स्टेशन ने, जैसे ये था, अगर अब नाउ यू कैन सी दैट हियर एक स्टेशन की फ्रेम ये है, दूसरा स्टेशन another station have transmitted frame B, and now you see that there is a common duration among them. This is a point where bits are common, the time is common, actually this duration is common for both the frames. So you see that whenever one bit duration is also common, अगर एक bit की duration भी common है then there will be collision. ऐसा है like आपने सपोज ये फ्रेम ट्रांसमिट की और दूसरी फ्रेम एक बिट पर, इसकी जो लास्ट बिट है इस पॉइंट पर है, और इसी एट द सेम पॉइंट second frame started, second node starts the transmission of frame. So now you see that इस this point पर दोनों की फ्रेम, दोनों का एक सिग्नल जो है ना कोलाइड हो जाएगा. दैट मीन्स दोनों की ये वन बिट वाली जो पल्स हैं दे विल बी कंबाइंड. सो दिस वी विल कॉल इट कॉलिजन. ओके, सो होना क्या चाहिए था कि ये जो पॉइंट है इसके बाद ही, इस पॉइंट के बाद कोई अगली फ्रेम ट्रांसमिट होती तो ठीक था. सो नाउ यू सी दैट ये जो टाइम है ऑलमोस्ट दिस विल कम, ये एक टी एफ टाइम है, वन टी एफ एंड दिस इज ऑल्सो 1 TM. सो टोटल जो टाइम होगा कितना हो जाएगा 2 TF. ओके, सो बेस्ट केस क्या है कि ये जो 2 TF टाइम है इसमें कोई भी एक फ्रेम नहीं आना चाहिए. ये टोटल टाइम है यहां से और ये ड्यूरेशन तक, अगर बीच में कोई फ्रेम नहीं आई, मैक्सिमम ड्यूरेशन ये है TF का, दिस टाइम इज कॉल्ड वल्नरेबल टाइम. और इस ड्यूरेशन में देयर शुड बी नो फ्रेम, नो अदर फ्रेम शुड बी देयर, ठीक है। सो अगर वल्नरेबल टाइम में देयर विल बी ओनली वन फ्रेम, देन योर ट्रांसमिशन विल बी सक्सेसफुल, otherwise your transmission will be unsuccessful. So now let's talk about what is the throughput of ALOHA protocol. So we will not compute it. It is computed by using following Poisson distribution formula. So the throughput of the ALOHA protocol is defined like this: S equal to G into e to the power minus tg, where G is the number of frames transmitted per unit time. Okay. So or it is average frame transmission rate, you can say. This is average frame transmission rate. So S is the throughput which is computed by G into e to the power minus tg, and अगर आप S को compute करेंगे तो G की 1/2 वैल्यू के लिए you will get this value. So maximum जो वैल्यू है S की है, आप इसको डिफरेंशिएट करेंगे, दिस इज एक्चुअली ए फंक्शन, आप इस फंक्शन का अगर क्या कहते हैं मैक्सिमा कैलकुलेट करेंगे, मैक्सिमा, सो यू विल गेट दिस फंक्शन विल बी मैक्सिमाइज एट दिस पॉइंट, g इक्वल टू 1/2 होगा, देन इट विल बिकम मैक्सिमम. ओके, so the maximum throughput offered by ALOHA is only 0.184, that means 18.4%. so the ALOHA का throughput है, it is 18.4%. so you see that it is very low. You can see that, and you can understand like this: if you transmit 100 frames, out of 100 only 18 frame transmission will become successful, roughly 18 frame will be successfully transmitted. So the throughput of this protocol is very low. Okay, so that's why this ALOHA protocol was not used. Earlier it was implemented, now it is not implemented. So now question arise hota hai ki what was the issue or what was the problem with this protocol, or how we can improve it. So the improvement of over ALOHA was slotted ALOHA. So I think we should do this. We will discuss ALOHA, slotted ALOHA protocol in next class. We should finish it, otherwise class will become very long. Okay. Okay,